All right, good morning. Today we're going to look at the basis of trigonometry. Trigonometry is the most useful. It's the one out of geometry that you guys will see in Algebra 2. There's an entire class about trigonometry. And so today we're going to look at what we're basically going to be working with. We're going to be looking at the top of it all. We're going to be looking at just the trig ratios, how you get them, and not quite how we can use them, but just what they are. So first thing we want to notice is that trigonometry, we're basing off right triangles, and we'll talk about why in a second. But here's just a couple things we want to look at. First off, we have a right angle, so we have some right triangles. Oftentimes in right triangles, we'll name once you get a little bit higher, you'll name with the Greek letters, but right now we're just doing capital letters. And then if you see across from it, so side B is created by angle B, but it's lowercase. That's just how we kind of simplify things a little bit. But both of these have an angle of 40. So the first question we have to ask ourselves is, are they similar? And yes, they are. And you know they are similar because of angle. We have a right angle, we have a 40-degree angle, 40-degree angle. So they're similar. So now I can come down here and I can look at my side ratios. So with my side ratios, I can go ahead and I can quickly say, well, let's just take two of them. Let's take A and C. So I'm going to take A over something and C over something. Go to my black pen. Equals. These are from my similarity ratios from last time. So A is between the right angle and the 40. So that's compared to X over here on the smaller triangle, and C is compared to the opposite side on there, the hypotenuse, and that is going to be Z. So now, this is what I want to do. I want to cross multiply these, and we'll start to see something here soon. So we end up getting Z times A equals C times X. Alright, now I want to divide again, and I'm going to divide both sides. I'm going to divide this, I'm going to divide over here by A, and I'm going to divide over here by A. So that gets rid of this, right? So all I'm left with is Z over here. But then I have all this stuff over here, so I'm going to actually end up dividing both sides by, I'm going to divide X as well. I'm going to divide X on both sides, so I have Z over X equals C over A. And what do you notice? It looks the same, but how is it different? If we look over here, A and C are from the purple triangle, they're on top, but over here, they're in the same ratio. And so what we've created is we've said, well, not only in similar triangles are the sides all the same, on different similar triangles, but within the same similar triangle, I can now say the hypotenuse compared to this leg length is going to be the same as the hypotenuse compared to this leg length. And so now we are looking at them in, I think I have it written down here, the same triangle. So now what this means is now we don't have to look between two triangles. We don't have to have two triangles as long as we have a right angle. As long as we have a right angle and one more congruent angle, we can use this trigonometry. We can say, well, if I know the side length between, if I have just a triangle over here, and I know that this is 7 and this is 40, I can say, well, I know a lot of stuff about the 40-degree angles because I know that it's a right angle. So maybe I can figure out what this side length is, and that's what we're going to be doing. Why does that have to be a right triangle? That simply just narrows it down. A right angle is common, and so we trigonometry is study of right triangles. And so now, instead of looking for 2, we know that, okay, we always have that. So now we're always looking, okay, 40-degree angles are the same, 60-degree angles are the same, 180-degree angles are the same. And so that's why we want to find a right triangle. That's basically the only reason why. It's not that it's special. I mean, if we could say that we're dealing with a 100-degree triangle and always have a 100-degree angle right here, and then that ratio would always be the same. But 100-degree angles are uncommon. 90-degree angles are what is the most common. And so we're going to use that. So when we're looking at them, we're going to look at 3 different ratios between the triangles. And what we're going to talk about is the 3 ratios are sine, cosine, and tangent. Sine is oftentimes going to be looked at as 3 short letters, S-I-N. It's not sin, it's sine. But then we have to be specific. Because what we're going to look at is we're not going to do trig on the right angle. That's always there. We're going to do trig on A and B. And so when we look at A and B, we're going to say, okay, well, I have the sine of what angle? And remember that when we had our function notation, we had the function of x. And so this is going to be the sine of, and then in here, I'm going to put an angle. What angle are we going to look at? So I'm going to look at A first, the sine of A. So I think I got ahead of myself a little bit. What we first want to look at is what these are. And so sine itself is the ratio that we're going to look at that is between the opposite side of the angle. And that's going to be over the hypotenuse. The cosine is going to be the adjacent side over the hypotenuse. And the tangent side is going to be the opposite side over the adjacent side. So when I look for the sine of A, I'm going to come over here and say, okay, well, what's the opposite side? So I'm looking for a ratio. First off, okay, the hypotenuse. The hypotenuse is always going to be right here. The hypotenuse is always the hypotenuse. It's always the hypotenuse. The hypotenuse is the opposite side of the right angle. Is the opposite of the right angle. So that's C. So I know over here that I could go ahead and say, all right, there's C. But then the opposite side of A. Well, opposite is the side that's created by it. Opposite and adjacent. Adjacent means next to. So opposite is going to be the side that is not touching it at all. So over here, the opposite side is A. So I can come over here and say my sine ratio is A over C. I don't know what A is, but I know the sine ratio is A over C. Alright, well then the adjacent side is going to be the side next to A. And it's going to be, so I can say that the cosine of A equals, well, the adjacent side is B. So it's going to be B over C. And then finally the tangent of A equals, well, it's opposite, so the opposite side of A is A, and the adjacent side of A is B. Let's take care of all the ratios. We have 3 different ratios. The one thing we want to look at is, okay, well, what happens if I change it just a little bit? What happens if I look at the sine of B? So I'm going to get rid of these. We'll remember that. So I'm going to say, okay, well, now what about the sine of B? The sine is the opposite over the hypotenuse. And so I now look at this. The B, the hypotenuse stays the same. It's still over C. But when I come over here and look, okay, well, what's the opposite? The opposite is now moved to be, okay, well, hold on 1 second. The opposite has now moved to be over over here, because that's the opposite side, and the adjacent side is now moved over here. So now the opposite side of B is B. If I looked at the cosine of B, well, the opposite side, the adjacent side of B is A. And then if I look at these, the tangent of B is now opposite of B, which is B over A. So now look at what happened between these two. Now, just between the same right triangle, cosine of A became sine of B. The cosine of B is equal to the sine of A, but then these are reciprocals of each other. That's just something to notice. You don't have to necessarily look quite at that. But so those are the ratios, and so what's important is making sure that we label what side we're looking at. So let's go try it. So find 3 trigonometric ratios for the acute angles. So my acute angles, so again, I'm not doing it on C, but I'm looking at B and A. So let's say, okay, I'm going to find the sine of A, the cosine of A, and the tangent of A first. And then we will scroll down and we will find the sine of B, the cosine of B, and the tangent of B. 4 minutes here. Alright, well, sine of A. Sine is opposite over hypotenuse. This is adjacent over hypotenuse, and this is opposite over adjacent. So if I look at A, which is up top there, covered right now, the opposite side of A is 12. That's the opposite side, so this is going to be 12 over 13. That's it. That's my ratio for sine. That's the ratio. I don't know what angle A is, but I know it's always going to be between them. And then cosine of A is going to be the adjacent side of A, which is 5 over the hypotenuse of 13. And then tangent of A is the opposite of 12 over 5. Now, for my sine of B, I can go ahead and say that my sine of B, my opposite side, this now becomes the opposite, and this now becomes the adjacent. So the opposite side is 5 over 13. Cosine of B is going to be 12, the adjacent, over 13. And this is going to be 5 over 12. And I found the 3 trigonometric ratios for each acute angle. That's all we're looking for, just that ratio there. And there's the last thing that we want to look at, is finding this side. So if I looked at the sine of y, I know sine is opposite over hypotenuse. And so if I find my y here, I go to the opposite side, and it's 3 over hypotenuse, which is 7. Check. But now with the sine of x, if I look at the opposite side of x, I don't know what it is. And so, much like the first section, we can use Pythagorean theorem. So I'm going to say 3 squared plus x squared equals 7 squared. 9 plus x squared equals 49. And we're going to have x squared equals 40, and x equals the square root of 40. Normally we might reduce. When you guys get to algebra 2, you will reduce those, but just because of the situation, we're not going to worry about reducing. So I'm just going to keep it the square root of 40, and so this is going to be the square root of 40. And so I have that the sine of x is equal to the square root of 40 over 7. There you go. That's what our trigonometry is. It's just that looking at the ratios. The next video that I'll post on Friday or Monday is going to be about using those trig ratios to find side lengths, but right now we're just looking at finding them. So you want to remember that we have that the sine is the opposite over hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. Making sure that you look at what angle you're dealing with in each of those. Hope you guys have a great day, and we'll talk to you again soon.